Hi everyone, welcome to WeeklyWed at Business School of AI. WeeklyWed is our happy place to share, learn, discuss, and explore. WeeklyWed occurs every Wednesday at 9 a.m. Pacific time. I'm your host, Yashaswini Vishwanath, and you can call me Yash. I'm logging from Bangalore, India, and I would like to know where you're all coming from. Please type away your name and location, and we would like to get to know you better. I work here as technical lead, and I'm specifically learning AI and focusing on AI ethics. I'm student of Sudha in her AI ethics class. I was a past student and present student. I'm going to be able to interview an amazing speaker today. Okay, so today, this is part of October's theme called AIoT. So today, we are going to go up the stack to one more level to focus on sensors, to understand how sensors are connected, what sensors are connected, and how do they come together to build the autonomous vehicle. But we're not talking about perception and running the autonomous vehicle at a computer vision level, but how do the sensor data come together to create perception, to create an ADAS feature, or it could be an autonomous vehicle. And the schedule today is, we're going to have the speaker that I'm going to introduce in a minute. And following that, we are having one of our students, Suresh Lokaya, who's going to be doing a demo of his project where he's built a machine learning model from the live lab machine learning class he just completed. And it's exciting and it's relevant today because he's used mobility data specification data, which is MDS data. And that is the data that data standard format that KiwiBot and many other sidewalk robots and scooters give to the city so that they can come up with useful applications. So we'll see what Suresh has come up. So that's the plan. So without further ado, let me introduce you to Baptist. Hi, Baptist. How are you?
Hello, Sudha. I'm all fine, and you?
Good, good. So do you want to just tell us a little bit about your background? Because you, first tell us, where are you joining us from?
I'm joined from Poland,
Okay.
in Krakow.
Okay. And you have worked in automotive industry. I saw you were at Renault and you're at Aptiv. So tell us a little bit about your holistic background, not just your current job. And we are not talking to you because you're at Aptiv or this recording is not an official interview from Aptiv. So
No, sure, but just to give you a quick introduction, I started my career at Renault as an onboard diagnostic developer. So basically, all the strategy implemented in the car to ensure everything is working properly, either from an electrical perspective or a sensor and things like that, or also the strategy for example, exhaust treatment to ensure the car emissions are at their nominal level or close to this level. And
do you come from a engineering background to do that? Do you come from automotive engineering or what?
Yeah.
Okay.
So then I wanted to know more about the engine control unit, and I moved to Delphi, where I've seen a bit of everything. And basically, I did that for 10 years. for software development, still for engine control, for validation, extensive test, also with the customer during test trip in extreme condition, warm and cold. So, and then I decided to return in the development part, and with my seniority, I could get the responsibility for more complex task. It was interesting. So I was especially in charge of control unit power management strategy, and also all the electrical diagnostic. So yeah, there was a lot of regulation aspect, and also some kind of safety to take into account. And then recently, I decided to move to ADAS because, as you know, the combustion engine, the future is not bright for that. So I was interested for ADAS already. It's a great challenge for the future. And yeah, so I did train myself out of the job to know the basics and get familiar with the context. And yeah, finally I could get a job this year as a function owner for ADAS.
Good. So Delphi Technologies is a tier 1 provider, right? And Aptiv is also a tier 1 provider, or they're tier 2?
Yeah, in fact, Aptiv was part of Delphi before.
Yeah.
And when we did, they split the company is two different branches, one for powertrain of Delphi, and the second for mostly ADAS with Aptiv.
Yes. So we have a lot of students here who have taken my autonomous vehicle masterclass or AV data masterclass. And so they are very interested in the ADAS and the AV side of the house. So it's awesome. So just to set context, Delphi Technologies is a tier 1 provider, which means they provide supplies for the auto, and they split off their powertrain unit outside, right? As Delphi, they left it, and everything else, which is the electric and AV side of the house, is what is Aptiv, where you're working. And there is Motional, I believe, which is a Delphi partnerships with Hyundai. So where if anybody is watching this and they're interested in AV data, the open data that comes from computer vision, the 2D, 3D perception data that you would see, that is shared by many of the other AV technology companies. Similar to that, you will find it from Motional, but Motional is also part of Aptiv. So there's so much more in Aptiv, but we want to hone in on your experience because having moved to ADAS from your path that you've come from, you can talk to us more about how things are done. So it's not just here's the computer vision algorithm and here we do perception, which we love to learn also. I like the idea because we are talking about AIoT as our theme. So we'd like to go to the sensors. So what I'm hoping today is, hello, everybody who's here. Thank you for joining us. You can share your experience, tell us where you're joining from in the chat, because you're going to learn a lot from this conversation, but I'm hoping you'll have questions that I can field so that, we can make it more interactive. And also, I'm seeing Kritika here in the audience, and she comes from a very strong automotive background. And there are people who have from my previous AV data class, like Emmanuel. So we can actually have a fun discussion, right? So that's my hope. So chat away, and then you can connect with each other if you chat and say, if you want, you can share your LinkedIn, that's my hope. Okay, so let's get started. So tell us what is ADAS first, for people who are not in the ADAS AV world. Tell us what is ADAS, and then we can
I think
sensor.
it's useful to mention first the different level of
5 levels
autonomy
yeah.
From the Society of Automotive Engineers. Yeah, basically you have a different level of autonomy from 0 to 5.
Yes.
Only the level from 0 to 2 are, I would say, ADAS relevant. And then from 3 to 5, the so-called autonomous driving
Yes.
levels. So let's say the difference mainly 0, it's sensing only, which means it's sensor that will eventually feed back a warning signal to the driver to help him identify a potential hazard on the road. Level 1, when we start to have a system that will potentially take over the driver on regulating vehicle speed. So it can be,
Yeah, I just thought I'll pull a chart to show that.
So it can be, for example, an adaptive cruise control that will regulate the speed longitudinally.
Okay.
Or lane centering. Basically, if I can give an example, you have a blind spot monitoring that will check if you want to overtake a car on the highway, if the lane on your left is free, if there is no car in the back of yours, and if you can safely overtake. Otherwise, it may send a torque to the steering controller to maintain the car in your current lane. So there is it's an intrusive system. Basically, level 2 is a combination of 2 different systems that will interfere at the same time. For example, lane centering and adaptive cruise control. Here you have both longitudinal and lateral speed regulation at the same time.
So most of the companies who are saying AV, or at least Tesla's, which is not technically AV, but now they have this thing called full self-driving. The starting point is for the car to localize itself and to identify lanes. So it just says, okay, I'm staying between the 2 lanes. That's the basic level.
I would say the state of the art in production currently is level 2, which means we are able to maintain the car in the lane, to regulate the speed, to adjust the speed if we identified another car ahead. So to slow down the car and resume the target move away. So that's doable.
So those features, those ADAS features are being baked in. So instead of Waymo or Cruise saying, okay, we're building a self-driving car and we're going that route, the OEMs are taking these ADAS features and they're putting it, or these self-driving features, level 2, level 3, maybe there's more, we'll talk about it. And they're incorporating it in the existing cars, right? So we have this keeping within the lane feature in most cars these days, right? Advanced expensive cars. Then the What about like checking whether the car is too close to the car in front of it? What is that called?
But in fact, this one is part from the adaptive cruise control.
Yeah.
If the radar detects you are too close from a vehicle ahead, it will slow down automatically the car. It will send a request to the steering controller, not the steering, the braking controller, to slow down. And you can even adjust the distance between your car and the vehicle ahead, the minimal distance to keep for safety. Such the computer will then adjust the speed automatically depending on the distance you've set.
So in some of the cars, I've seen that they just make a noise, right? If you get too close, they have a certain amount, a certain distance they want to keep in front of the car.
It depends. Yeah.
They don't actually control the speed in regular cars without adaptive cruise control. They just beep that you're too close. And I've seen, some cars do that, just a ADAS feature. But it's interesting that it can actually slow down and control the speed to bring it down. So then the person keeps the distance as they're driving. So that is still level 2.
Yeah, basically, I can quickly explain the difference between level 2 and 3.
Yeah.
Level 2, the driver is still responsible to drive the car, which means he should always keep the control of the car. And in level 2, even if all these ADAS features are activated and in operation, it's requested that the driver always keep hand on the steering wheel. There is a sensor in the steering wheel to make sure that the driver actually has the hand on the steering wheel. Otherwise, there is a warning signal displayed on the dashboard to tell the driver you are not present, so I will deactivate the ADAS. And the driver has then to take over the control. In level 3, the driver is not requested anymore to have the hand on the steering wheel. It's only requested to take over the control of the car in case the system asks him. Because in level 3, the system is not able to drive in all conditions of the road.
Yes.
Basically, we can see also on this picture, there is a blue part on the left and a green part on the right. Until level 2, the liability it goes to the driver.
Yeah.
Whereas from the level 3, at least a part of the liability is transferred to the car manufacturer.
Yeah.
Which means it's still hard, let's say, to go to production with a level 3 car because there is no proper regulation yet in place for that to transfer, let's say, the liability to the car manufacturer. There is a problem also with the insurance.
Yeah.
So all these aspects are not cleared yet. And I would say the technology progress. They are even now with some manufacturer level 2 plus, which means it's already more refined than level 2, especially in terms of driving condition. You can activate your ADAS feature in more road condition, Typically, I gave the example of ACC. It's not only on the motorway. You can use it also on country road. Also, the lens.
So it
Yeah.
shifts the liability because now the driver decided to switch instead of the car automatically switching, right? So the driver has chosen to go to the ADAS mode. That means the liability is on the driver if anything goes wrong, other than safety itself,
Yeah.
right?
Yeah.
Yeah,
Yeah,
it's a sad reality, but I think that goes into the business side of decision making.
For now, whatever the driver is doing, he's responsible for the choice. If he uses ADAS, he should be able to take over at any time and anyway keep the hand on steering wheel. He's liable for everything can happen.
Yeah. So I saw with Tesla saying you will give you full self-driving FSD feature. They're turning it on by an over-the-air update, and they're saying we'll give it only to the users, the drivers who are safe drivers. And so to even opt in for that, people have to say, I want to be part of the beta, and they give permission to monitor their driving behavior. All that we've spoken in the class, it's just like coming to life. They are monitoring how good a driver you are, and they have criteria on what kind of things that you're doing that actually changes your driver rating. And they're very transparent with the dashboard, giving that, and people are competing for that and say, oh my God, I got an 89 and I want to be a 99. And they said, you have to be 100 on 100 or 98 or 99. Only for those people we are giving this access. So essentially, it's a game of making the user accept the liability that if anything goes wrong, it's on me, not on you. And the company has enough to prove that this driver was safe when we gave control, but the driver chose to do this, right? So it's and in adaptive cruise control with the level 2, with what you're saying, the OEMs are not playing the game of your insurance that is on you openly with data, but they're doing the same thing because the driver has to take control. So walk us through what is level 4, just to get the full picture for everybody. And I want to make sure we talk about what does it take in building the level 2 versus level 3 ADAS, because you have experience on both.
I want to talk a little bit about higher level. Basically, level 5, it's all autonomous in every road condition.
Yes.
So you have nothing to do. You can even remove the steering wheel because you just sit and it's fully autonomous. So in between, there are intermediate level. Basically, that's level where the car will not be able to be autonomous in certain road conditions. Typically, the weather, overnight, things like that. So when in this intermediate level, the system can request the driver to undertake the control. Typically, level 3 is mentioned here.
Yep. Okay. So I was just looking at the comments. It's my job here today. So, okay. So you got us on the same page, and most of the pilots that is happening in the AV space, they're all claiming that they are level 4, right? That's what they're, because they're driving autonomously, maybe in the road condition that they're trained for. They can't, if the car is trained here in California, they can't go and run in snow in Switzerland, right? So, or the different road terrains. I've heard the car in India that was trained in a bumpy road, in a hilly road condition, and they're going to be great there, but then they might not run in the snow, or they, even a flat terrain might look look different. Okay.
There is
So
also off-road condition, and you
yeah,
have to train the car also in this condition.
yeah, that means the car has to be trained again and again and again every single time. It's not scalable. So let's come back. Let's leave the level. So level 5 doesn't exist, and even I talk to any
No.
engineer, they would say no. Yes. Okay, so let us come back to level 2 and 3 and help us understand, from a sensor level, since we promised that, right? So
Yeah,
since
so
you've come from the non-ADAS, non-AV world to this world, tell us what is the difference and what sensors come together. So there's a sensor fusion that by which the car identifies, right? I don't want to throw
basically,
words
I
here.
found a picture on the internet. Maybe I can share it.
Yes, I can make you.
Or I send you the link here.
You're sending me the link. You should be allowed to share if you want to share directly.
Okay.
Okay. So if you guys have comments, I see a comment from Kirtika. Okay.
There you go. So you have the different sensor type on the right, where it is on the car and what it allows to do. So basically, adaptive cruise control. Emergency braking is also a feature that goes often with adaptive cruise control. Pedestrian detection, for example, we have this moving off strategy. When you start with the car, if a pedestrian is detected just in front of the car, it will send a warning. That's very useful typically for trucks because they have a high position, and with a little child or cyclist sometimes can be overseen. So this sensor is here to help truck driver basically to pay attention. Collision avoidance, that goes with emergency braking. Basically, the car is not able to stop. I had the opportunity to do some tests a few years ago, and it was only able to slow down till 30 kilometers per hour. So that was not full stop. But now with this strategy, the vehicle comes to a complete stop. Then what else? Yeah, you have this blind spot detection. So if you are on the highway and a car overtakes you, the driver will see a little light on the dashboard or in the mirror to inform him, beware, there is a vehicle coming. It's also implemented on the other side. For example, if the car is turning, if you put your turning indicator and there is a bicycle coming along the car, it will be also detected and a warning sent to the driver. So otherwise, yeah, you have cameras everywhere. So that's typically useful to identify a lane on the road. You will have the camera, it will be processed, and lane identified. Road user also identify whether it is a truck, a car, a bicycle, a pedestrian. All of that will be done in the image treatment. What else? You have ultrasound as well. That's mainly for park assist and rear collision warning. So yeah, but the main sensor you have, and then we can show something else.
So that's the entire set of ADAS features. But
Yeah,
the
exactly.
identifying pedestrians, we always think of, when you think of it from a computer vision, object identification, we are thinking about all different combinations of pedestrians and ducks and other cars and everything together. But from an AV training perspective, it's individual AI models that are doing different things. So it's interesting to see how it is productized as one ADAS feature, and whether the ADAS feature is going to give the experience of just giving a sound, or whether it is actually tying to the adaptive cruise control and taking control and doing something to slow down the car. Or
it depends typically for level 0 features, like, for example, pedestrian detection.
yeah,
It's just an information. So it will be detected and then a warning sent to the driver. So in most case, it will be a lamp on the dashboard, an
yeah,
indicator to inform the driver about the potential hazard. Now, if you have, in the case of adaptive cruise control, if it's active, it will directly interface with the engine control unit, and eventually also the brake controller to regulate the speed, slow down the car if necessary,
yeah,
or accelerate. So here it will be transparent for the driver. The driver has nothing to do.
yeah. So giving the experience, so it's like a slow way of taking the AV features and bringing them as ADAS products. So we need people
Yeah.
like you, yeah, people like you to figure out what is the right way to productize this. We have another class called AIX where we talk about designing artificial intelligence and creating the experience. So in the car, it's very fascinating. So the same thing where you spot a pedestrian, as a consumer, I would say, oh no, you need to stop the car and not let the car continue because it will hit the pedestrian. But to productize it and say, hey, truck driver, I'm notifying you there is a pedestrian there, and maybe beeping or showing on a screen is one kind of experience, thinking about where the liability is
But
shifting.
typically, yeah, this is just for moving off detection, what I was talking about. Then you have also a permanent detection at the car, and if an obstacle is detected, whether it is a car or what we call a vulnerable road user, which means a bicycle or a pedestrian,
Yep.
it will be seen by the camera, and in that case, it's the emergency braking strategy that will be put in place, which means the car will stop. The moving off detection is more if you are static, the car is about to move, but it is still at vehicle speed equals 0. You want to start, and the car detects there is either a pedestrian or a bicycle ahead, and if you start, there is a risk of collision. So in that case, it will inform the driver, beware. But if the car is already driving at, let's say, 50 kph, and there is something detected ahead, like a pedestrian, for example, then this emergency braking will come into action and stop the car.
Okay. So can you get out of sharing? We want to ask you some questions.
Yeah.
This is good. Hello, everyone. I see some chats, but do you have any specific questions? We have another 10, 12 minutes with Baptist time. So I want to see whether we should focus our questions on some specific direction. So for me, one thing is, as you're explaining the different ADAS features, you're talking about different sensors. And what I got from you today is that the productizing of how this is done, there is so much power in that productizing. It's not just the ability to sense or send that information to the car, to some central unit, but how it is productized and how it is communicated and whether it gives control to the user is very black and white. And so that part is kind of scary but fascinating. The other thing is, since you work on ADAS, let us take a step back. Tell me, what does it look like? It's we hear about level 2, level 3, the driver has to, have their hands on the wheels, and the driver is there, but will put the hands on the wheel and be given control, right? Is theoretical when you hear it in that SAE level boxes. And then when you build it and say this sensor, that sensor, we're getting this data, it's still engineering, right? But now you're doing a different level job. So you've done more system engineering. So you know what the different pieces that are coming together. But from a business standpoint, it looks like somebody is thinking about insurance, somebody is thinking about the business risk, somebody is thinking about productizing, customer experience, even the engineering has multiple parts to it. So help us understand, what does that look like? Who all come together? What are the different roles? What does that look like, and how you build out this ADAS capability? Like I'm thinking from a product management perspective. I don't know if it is called product management, whether this role is called something else. Help us understand what that looks like.
First, how we design things. The customer, so car manufacturers, that come to us and say, okay, I need to design this system. So here with ADAS, there is a regulation part, because the regulation requires the manufacturer to have such a feature on their car. So that's the point. Then there is also a problematic that for the driver, who are the customer of the car manufacturer, it shouldn't be intrusive or unpleasant to use. Basically, it should be smooth to use and perceived as a help and not as an intrusion. Otherwise, the risk is that the driver will be quickly fed up with the system and will deactivate without using it. And this is not what we want, because basically these systems are put in place to reduce the risk on the road. So it's better if it's used. So we have to consider all these aspects. Of course, on top of that, there is a cost aspect, because it should be as cheap as possible. So there is no compromise to do on the safety, but most of the time the manufacturer wants to limit the cost for such an implementation, because that's not something they can easily sell to the final client. Basically, most of the client will not buy a car for ADAS. They will buy a car for because the fuel consumption is low, because cheap, or I don't know what. But ADAS is still not, the client basically are not familiar with this concept yet.
So ADAS is more an upsell. It's like an extra nice to have feature.
Yeah, it's nice to have. Yeah, exactly.
Though it is driver safety.
They are not necessarily to pay for that.
So is it because the automakers are not marketing it right to to
No, but the impact for us, of course, considering they cannot sell that system that much, but the impact is sometimes the cost is limited. So it will be less limited with premium manufacturer. But still, there is a cost constraint.
Okay. Okay. Does anybody have any question on the different roles that come together? Because I'm just imagining what that would look like in a company with so many different roles, trying to make this decision whether it is ready to go out. And Kirtika was asking about regulation. In terms of regulation, we don't have it. The short answer, we don't have it. All the level 4 cars, we have about 60 pilots in California.
No, for that we don't have anything, but for ADAS we have already.
ADAS, we have permission from all the government regulation.
Yeah, and I mean these features are required by the regulation.
Yeah. And also in US, in Europe, you have to test the feature and then you have to get it approved. In US, it is on the auto owners who say, yes, we say it is safe and we will publish the safety features, right?
Yeah, it's a
safety benchmark, right? Okay. They don't need permission to actually send it out. They just need to say, liability is on us. We tell you that this is safe. Because of that, they kind of self-regulate, right? And they're bringing that to the self-driving car, and that's where the conflict is, because they're saying, don't regulate us, we'll tell you when it is safe, believe us. And so that hasn't happened yet. Okay, so there's a question from Emmanuel and from Kirtika. So Emmanuel, since you asked it earlier, maybe you should go first.
Hi, can you guys hear me?
Yes.
Yeah, I wanted to find out more on the nitty-gritty details in terms of, is there a particular strategy of using certain type of sensors versus others? And is that based on the kind of response time, or is it based on something else? So in other words, would you use like vision system versus using ultrasonic or other means?
Emmanuel was part of the class. Emmanuel was part of the class where we made the students create a hypothetical ADAS feature and then do a cost and pricing for that, and figure out how much data is collected from the sensor. So we focused on data, cost of data, and then up to the cloud. So Emmanuel comes from a strong background where he knows audio vibrations and sensors. So no wonder that question came from him.
I would say, yeah, it depends on the need we have in terms of input. For example, if we need to identify the lane and other road user, obviously a camera is necessary. For adaptive cruise control, we don't need a camera. We just need to detect target vehicle or other road user ahead. So a radar is enough. So I would say, yeah, depending on the need we have, we put in place a different sensor on this one. And yeah.
So back on the sensor question, is there a difference based on you're coming from one particular company? Is there a special competency that some company would focus on some kind of sensors, and so an OEM would go to that particular tier 1 provider versus your competition maybe?
I don't know so many company. I know in my company we have an external supplier for the sensor and the processing. So yeah, I think the level of complexity is so high sometimes that you have really some company with the knowledge to do things, and when you need really a specific knowledge, you need to buy it. You cannot do everything yourself.
So you go by the supply chain of the suppliers that who
yeah,
have a
because
brand in the industry that they know.
the core of our activity is the controller. So then if we need just a basic input with a sensor, okay, we buy the sensor, and we do all the software part ourselves. If we need more complex things like a camera with image processing, here it's a big team dedicated to this activity. We don't have necessarily the resource in terms of people, in terms of money, so and sometimes in terms of knowledge as well. So depending on your timeline, on your budget, you decide or not whether you want to do it internally or take a solution at another company.
So are there providers who are, I know your company is a tier 1 company, and we said we will not make it about your company, but are there tier 1 providers who are specializing in certain ADAS capability? Because it all comes down to, you have your supply chain and you're bringing your sensors, but you're building a product essentially. Is there a moment? I'm just thinking, is there a productizing business reason where one tier 1 provider might become so good at a certain ADAS capability with the layer of all the layer of the tech put together? Is that happening? Or just
basically, we are not focusing on one feature in particular. We can build all sorts of ADAS, because basically it's pure software. So once you know how to do software, you can do everything. There is no restriction. It's not specific like indeed the sensor, where you have a LiDAR, radar, and a camera. And here you need the specific knowledge for each. With software, you can do what you want. So basically, yeah, then the job, in fact, consists in collecting all the information from the sensor, doing what we call sensor fusion. And then, yeah, we have the controller for ADAS. So basically, it's an equivalent of the engine control unit. So it's like a mini computer that take all the input from the sensor, do the sensor fusion, and then you have a piece of software that make a decision depending on the input, what we should do, and how we should interact with car powertrain, with the brake, with the steering wheel. So that sort of thing that we have to design in our controller.
Okay. We are actually coming to the end of our time with you. So a good speaker actually wakes up us to learn the next level stuff. So that's what I'm feeling about this. So I'm happy. Before you go, maybe Kirtika has a question. Kirtika, do you want to just speak up and ask the question, and then we will let Baptist go? And Baptist, I put his full name and as his LinkedIn, so you can connect with him. But he's also part of our current class. So if you're part of his cohort, maybe you'll get to interact with him, and you might be lucky if he's in your team in the no-code AI database, the data science course that we are working with KiwiBot to build out a whole ML model. Kirtika, do you want to ask that question or not?
Yes, Sudha. Yes.
Yes.
Good to know Baptiste is also from automotive background. A specific feature that you have worked on, which is relevant to L3 or L4 driving automation system. Like, could you explain us, like, how did you take from taking the feature into consideration and building the model completely?
But in fact, I didn't work yet on level 3 and level 4 because we are working for OEM, and currently the state of the art for production, at least, it's level 2 maximum for this question of liability. So I work basically on this ACC feature. And now I'm working more on blind spot monitoring and moving off detection. So basically, the process to work on that is simply first to take the customer requirement, to discuss that with taking into account the regulation, see the technical feasibility. And yeah, then it's a work between us and the customer. Yeah, then I would say.
Okay.
Yeah,
Awesome.
it's quite straightforward. It's a normal project. In fact, for me, it's not unusual. And now you have this cycle we use where the system team identify the technical requirement based from the customer, from the regulation. We implement that in our system, and then we test on the vehicle. We adjust because most of time, first time, it's not satisfactory. And yeah, we can do also some joint testing with the customer to see if it meets their expectation. And then normally, if everything goes fine, it goes to production.
Okay. I would like to wrap up. I feel very sad to be that person, to do that. But this has been so wonderful to learn, and hope we'll get more of your time again as
Yeah, sure.
get to learn that. This is amazing how the things are at level 2, because we always thought it was regulation and technology. So there's the insurance liability, business risk, how they're productizing it, and the consumer is still not aware that this is all driver security enhancing. It's not marketed that way to them, so they just think it's a nice to have on top.
Yeah, it's really
That part is very sad. It makes me very sad because there's so much power in it's really keeping people safe, right, with adaptive use control. And yeah, so hopefully we'll get there. Maybe there'll be more education on this to the consumers. And yeah. Okay, so with that, I want to wrap up this segment. And Suresh, if you're still ready to do that, we would like to see a 10 minutes demo. And maybe, people who, if you want to drop off exactly at 10, you go, and we will share the recording. But I want Suresh to be able to show a demo. Suresh, does that still sound like a good idea?
Absolutely. If you guys are ready, yes, I'm ready.
Yes. Okay. Thank you so much, Baptist. If you're able to stay back, maybe you can cheer for Suresh. He's actually completed his machine learning. He's new to the whole machine learning world, and we took mobility data. And so he's going to walk us through. So without more talking, I'm just going to pass it on to Suresh.
Yeah. Thank you. You can hear me, right? I mean, there's some gardening. That is right. Yeah. I'm
always happy to cheer for my students. So I'm just going to hand it over to you, so we don't waste a single minute and we can learn from you. Thank you, Suresh.
Thank you. Yeah, so my name is Suresh. I work in the technology space. I may be new to the mobility space, but I'm always curious about a lot of technology, AI, a lot of IoT, worked in camera IoT and things like that before. Done a lot of innovation stuff, but very casual.
I'm just going to find your LinkedIn so people can connect with you.
Okay. So I'm very thankful for connecting with Sudha and being part of this class where I took where we were introduced to the trip data from mobility MDS, and then we were working on a particular project. So what I did is I worked on taking the trip data, building a model, and then I extended it further to deploy the model and put together an application. So I went all the way, not just doing an EDA of the data, but I went ahead and built the model and I built an application. My goal here is to, share the learnings and create the curiosity for whoever is excited, and they can go ahead and explore enough portions of the MDS and then come back and share your knowledge for the wider group, right? So what I'm going
people here are not familiar with MDS.
Right.
If it is not too time consuming, you can tell us a little bit, because we will be using that mobility data specification data for our project with KiwiBot, where we are going to solve a business problem for them with our no-code AI data science.
Got it. So what MDS is it's a short form for mobility data specification. So what it means is it's a group consisting of providers who are interested in standardizing the dockless vehicles that are operating within the city. So who are these groups? Basically, the government organizations or the vehicle providers. They are all part of the specification. So this is they come up with standards on how the vehicles have to operate and what kinds of information could be shared across to improve the life of consumers who are using the services of the city, basically, because the mobility devices are sharing the road with the people. So it is to improve the life of the people who are using the city, and the mobility vehicles are cooperating within the city. So basically MDS means it's a set of specification which these all of these companies and government organization benefits from. So that is in short. But what I'm doing here is in my presentation also, I'm giving you a lot of information on where you can find about MDS and things like that. Okay.
So I made you a host, so you should be able to share.
Wonderful, wonderful, wonderful. Okay. All right. Okay. So this was an exciting project. So what I did is we took the data from the Louisville data.gov website. And so they had given us data from 2020 for a period of 3 months. And so with the learnings from the class, we did work on this project where we did the data analysis, we built the visualizations, and then we built the models, and further what we did is deployed the model and the application. So this is just to introduce. I really like this this picture, so I added it up here. Basically, if you look at this link, it talks about different vehicles that are operating within the city of Louisville, Kentucky. So these are all the licensed operators that are operating, and so the data that is collected and resides in the data louisville.gov website has of many data that is part of MDS. This particular data that we are doing the analysis is trips data. Trips data contains everything about when the vehicle is operating, all the data that is coming in, from the vehicle, basically. Okay. So do you have any questions or any thoughts that I can answer right away? Because I know it's in the very early stage. Before I jump into a lot of details, I just wanted to make sure that this people set of group of people understands what MDS is. What are we trying to do with the MDS trips data? And before I show how we are doing certain things. Any thoughts or questions?
Were there different use cases you looked at? Because one of the things we do in the other class, right, with the Kiwi bot, the data science classes, we start with the business problem and then come up with multiple different ways that business problem can be solved, arrive at multiple use cases, prioritize, and then pick one, and then go build a model for that. So my question is, did you just start with a data set and a specific use case because your focus was in building the model, right? So you were not thinking of.
In this case, I was the data scientist here, actually. So.
Yes, yeah.
So what I did is, I just got so excited about, getting my hands on the data set and, digging through what I can find, right? So, so in this example, I'm just going deep within the data set and trying to figure out, what the data is speaking to me about. So that's what I jumped in.
Can you also help us understand? I know Julian taught you on specific steps of this, so he came up with the Google Colab, so you didn't have to write the code, but you had certain steps to understand the data, visualize the data. Are you going to walk us through those steps?
Absolutely.
Okay, thank you.
Absolutely. Okay, so as there is no more questions, so yeah, so Julian had shown us the Google Colab. So basically, if you do not have access to the Jupyter notebook and things like that on your laptop, you can leverage the Google Colab. But sometimes it can be a little slow because you're accessing over the internet and you're asking it to run the queries and things like that. But if you have a good enough machine, I think it should be fine. So for this particular project, we're using Pandas, the scikit-learn libraries from Python. So what I'm doing here is, my data analysis is, organized like this. Basically, I'm bringing the data. I'm doing some exploratory data analysis. I'm just looking at, what the data has at a very high level, trying to make sense of the data. And then, I'm doing some cleanup from the data that I've understood to make it look better. Like dropping, nulls and things like that, cleaning up the data basically. And then I'm doing visualizations to understand a little bit more about the data itself. Further than that, I'm doing the machine learning model. I'll just go into the details of the machine learning model and then how I deploy that model and how I built a Flask application around it. So here,
and what was the time frame of this? Because if you're not used to Python and you see Python on the screen,
I'm going to show you all that. Yeah, I'm
okay.
going to show you all.
How long did you take to do this whole thing from start?
Oh, okay. So driving out. Okay. I initially started off with, I would say about a week or a week and a half. I think I initially started off with using a different tool. But then it was not giving me all the controls that I would needed. So I jumped into using Pandas and things like that. So I would say about a week or week and a half to put together this particular thing. But the model building, improving the model and building the application was, I figured out, towards the tail end of the project. But yeah, I would say about a week or week and a half should be good enough. Because I'm looking at the trip data. So I think, expertise in the field is nice to have, but in the trip data, I'm looking at the trip data for the very, very first time. So I'll show you what I did in this. So in this place, I'm just installing all the required packages and then, updating those packages so that I have all the latest libraries. So this is how I get the data. By the way, I have loaded all of this in my GitHub page and things like that. When you get the GitHub page, you should be able to look at, get the data, and you can play with this actually. So reading the data as part of the as part of the EDA, you do, see how many rows and how many columns are there. This particular data file has 32,000 rows and 13 columns. And so I go ahead and figure out, what are those columns that are saying and what the data types are. So it has the trip data, start date, start time, end date, end time, trip duration, trip distance, and we have the lat long as well, where the vehicle started and where the vehicle ended. Additionally, we have, when the trip was taken and at what time the trip was happening, right? So we have all of that information in the trip data. Now, what I've done here is I've linked, this particular, data definition from the Louisville website itself. So you can, I have the links on this particular document as well. So this is what is data.louisville.gov, which has that information as well. So through this, I understood, what each of those fields mean. If they say day of the week is 1, it means it's a Sunday. 7 means it's a Saturday. So so before I jump into the whole project, I kind of understand what the data is saying, what the fields are saying, so I can wrap my mind around, how I should go about doing the analysis. And so here I'm looking at the top data.
Just to jump in, the actual live lab machine learning class is taught using no code. So the expectation was nobody really needed to know Python or anything. Julian gave a Colab notebook and then walked you through, and it was a 2-hour class, right? And then you had office hours and stuff. So because programming, you took that, you completed that, and then now you moved that to Panda. And you're doing, and you're showing us a different version of the same thing. Okay, exactly. Just wanted to be clear, because we don't do anything, we do everything with no code in all our classes. So I just wanted people to know, but I'm very happy when my students take that and take it up to the next level based on whatever their background is. Right now, if you had a BD person, they would have figured out to go sell this somewhere or do something else, or a product manager would go build a product with it. So
that is true. That is true. So it's basically finding the golden nuggets within the data. So, that's what we're trying to find out. If with no code AI, if it's much easier, we will definitely start leveraging, that aspects, which I'm part of your class. So that is going to be next set of learning, I'm sure. So in this place, I figure out what is the date range of this particular data. So it is from 2020-02, from the February to June, July, basically, right? So it's basically last year during these months. So this describe command does the, finds out the mean, median, as well as the percentiles for the particular from the data. So if you look at this, I'm doing some analysis of making some understanding of what the data is talking about, right? So if you look at my data here, I'm saying I'm making some observations. I would call it as observations. So basically I'm saying, the min value has zeros in it. Okay, which means, the trip duration cannot be zeros. So, what I need to do is maybe somebody started it and then they just stopped it. There was no, they right away stopped it or something like that, right? So maybe there is some invalid values. So we need to drop some of these things, or even trip distance as zeros in it. So as a data scientist, people, they look at the data and make some judgments on what needs to be happening for the cleanup steps. So in this place, I say, oh yeah, I have, day of the week is showing minimum and maximum. And this is the interpretation from this, schema here. And then I'm looking at, okay, so hour number, I can understand that, the data is from 06 to 23, right? So which means at 6 o'clock to 11 o'clock, they have the data in this database, right? In this data set. Now with that, discovery, what I'm doing here is I'm doing some cleanups. I'm basically, deleting duplicate rows, if there is any, right? Cleaning up zeros in the trip duration or trip distance. And then I'm creating a new field, basically because understanding ones and twos is not equal to understanding Saturdays and Sundays and things like that, so that it's easy for people to understand. So I'm noticing that there is no duplicate rows. I'm here what I'm doing here is I'm seeing how many rows does is either trip distance or trip duration is 0. It's about 72 rows. So out of the 33,000 rows or 32,000 rows, I have 72 rows that have this particular 0. So I'm dropping them, and then I'm seeing, okay, what is the new size of it? And then here is how I'm creating a new field for the string value of these values. So I've created a new field called as day of week string, basically. Now with all of this data, I jump into the visualization. So basically what I'm doing here is I'm handling the discrete data visualizations and continuous data visualizations. So basically, this is like a particular date, right? It says hour number is 1, 2, 3, or day of week is 1, 2, 3 kind of a thing, right? So it's discrete. And the continuous data, trip duration, trip distance are continuous data. I mean, so these you understand by looking at, all of this comes from understanding this particular information, basically, what you have and what, how you can interpret some of these things, right? And then what I'm doing here is I'm visualizing the lat long information. I just wanted to see, where these trips have been happening. So looking at this data, so it looks like, this tells me that, around 8 o'clock in the night, there's a higher peak of, vehicle trips that are happening. So I'm making some observations after each of those graphs and showing, shows a peak usage at 8 p.m. during the day. And then I'm seeing, so if I need to focus my attention on certain areas, and these are the observations I make after each of those charts, basically. And then, day of the week, it looks like Saturday is the highest, Sunday is the next highest. And so it's busy on the weekends. And Monday is typically the lowest, which kind of makes sense. And then what I'm doing here is, for the continuous variables, I'm making some box plots. So why I'm making some box plots, basically, I want to understand what the outliers are, right? So for instance, in this case, the trip distance has an outlier, around, 600 miles. Right, this is like way outlier. Maybe there's some issue with the data, or whatever, right? So we want to remove some of these things and do some cleanups. And trip duration also has something like in thousands. I mean, this does not make sense for us to do the analysis. Usually, here is a formula, right? 1.5 times of interquartile range is called as the outliers, basically. So what I'm doing here is I created a small method to remove the outliers. And so here, after the outlier removal, it looks much better. I can see the 25%, 50%, 75%, and then this is where this is a more manageable data set, basically. So basically, you want to clean up the data as much as possible, so that you don't get false predictions and things like that, because this is going to skew the data. If the 1,000 time duration is there, it's going to skew the predictions and things like that. So with that, with that new data set, I'm doing some correlations, and I'm seeing what makes sense. Which parameters, which fields impact has an impact on the other fields, right? So that's what is a correlation graph. And so this is the same representation in the heat map. So I know I'm talking a lot, but I just wanted to take one step and just recap. So basically, what we're doing here is we gather the data. we did some initial, exploring the data, the mean, median, the size of the data, columns and things like that. And then what we are doing here is we made some observations from that initial analysis. And then we jumped into cleaning some of the things that we are finding, which is the anomalies or the outliers, things like that. Now we have a sort of a clean data set, which is where we are building the correlation between, what parameters have an impact on the other parameters. Okay. So I hope you're clear so far. So in this place, so I'm looking at this correlation chart. What this tells me is that, the trip distance and trip duration has a correlation, but it is not a strong, in this data set, there was not a strong enough correlation for us to, make sure that, there is, if there is a trip distance, then, that equals to the trip duration. So this data set did not bring us the correlation strong enough, but which is fine. So even after this, right, so what I'm doing here is I'm making the observations here, some of the insights that are here. Trip duration to trip distance has a positive correlation. Trip duration to hour number has a positive correlation. So trip duration to hour number, right? So here, it's not strong enough. Usually it's like 0.8. That shows you, if the number is above 0.8 or something like that, it shows you a strong correlation. But in this data set, this is what we're observing. So if you look at the pattern, after every step, I'm making observation on all of these things. And so this is a joint plot. So these are all the different plots. I'm just taking the advantage of the pandas, various plots and what it can tell me about all of these, understanding the data itself. So in this case, we can see that, there's a lot of, data, where the trip distance is, a lower number, right? So which means, many vehicles took a shorter trip, and there are some vehicles that took a longer trip, which is fine. But this tells me, how many vehicles took a, short, trip distances, in the range of zeros and, less than 0.5 miles and things like that. This gives us an indication of how the data is distributed. So we did plots for, continuous variables. We did plot for discrete variables with the box plots and with the bar charts, things like that, histograms and things like that. Now what I'm going to do is I'm going to jump into the spatial data. So in the spatial data, we are using a provider called as Folium, which is where, we understand, where these, a little bit about where these strips have been located. So we are using the lat long for doing this analysis. So this is the chart of or the map of the Louisville. And then we are seeing where these vehicles are being operating. So we are doing a start latitude and start longitude. And so we are seeing that, the trips are focused in these neighborhoods, basically. And so what I'm doing here is, I'm seeing, I took a sample of the data because, we don't want to do a big sample of, it's about 31,000. So we just take a representative sample of it and see, where the trips are concentrated on. So around this downtown, I guess, maybe, right? So there's about, there's a concentration of all of these. I think this looks like, there's a hospital here. You can just zoom in and look at it. I think there's some hospital here or something like that. It's like the main street. It's kind of cool. I like this package a lot. So here there's a University of Louisville Health Science. I think you can see it here. So a lot of trips are happening around this area next to the Ohio River and things like that. So which is good. So I did another cluster analysis for my own, understanding. So this is a heat map of the the trips basically. And so this is the directed line bars for the trips. So basically this might mean, people are moving from here to here, or people are, the trips are happening from here to here, or things like that. So this is just to understand, how the trips have been happening basically. Okay, so this is all about the EDA cleanup, visualizing the data. Any questions or any thoughts?
Yeah,
Okay.
if I could interrupt, could we go to the correlation map? Thanks, this is wonderful.
It was very exciting. I mean, I enjoyed a lot. Getting my hands on this thing is very good. This one you're talking about, right?
Yes. So with this correlation, the deduction would be like the trip duration. We derive the independent variables which are necessary for building our model, if I'm right.
Right.
So
That's
what was your inputs in taking the independent variables? Like which were the variables that you took for building your model?
So in this case, I took the all 13 columns.
Okay.
Right. But if let's say the data set is like, let's say 50 columns, things like that, then maybe we would, because this chart is going to be humongous. And so this also goes with, it doesn't do anything with the string variables, right? So it does only with the numerical variables. So basically it takes up all the numerical variables that are there, and then it does the, lat long, does the heat map of that basically. And so you can, this one, you can play with different color maps and things like that to see, to really show, what is a strong correlation versus a, less strongly correlated and things. Or this is a negative correlation, right? So, yeah. So to answer your question, we took all of the fields from the data set basically.
Yeah. Thank
you. Okay. Now I'm going to jump into the machine learning model. I'm explaining what I'm doing here. It's very interesting. So what we did is, we did build a linear regression model, and we evaluated mean absolute error. The goal is to have a mean absolute error of being less than 5. And so what we did here is we went through, iterations. Because we did not get less than 5 for MAE, so we did build another model with using the decision tree regressor, and to see whether we are getting a value less than 5. So basically, we are just going through iteration to build a model where the model can reliably say, if you tell me this, I can very reliably predict this, because that's what we are getting to with this, all of these things, right? We are making the machine tell us for definitively or close enough to a correct answer that if the housing prices are this, these are the number of bedrooms, for instance, or something like that, right? So that's what we are trying to do here. So here, this is how so linear regression model, we built the Y, which is what we're going to be predicting on. So in this example, what we're doing here is, since there was no strong enough correlation to say trip distance and trip duration anyhow, but what we are doing here is we are taking we are going to be predicting on trip duration with other columns basically. Okay, so the Y predictor is the trip duration, and then we are just using the machine learning model to build a linear regressive model. So this is the works of it. So we are splitting it into a train and test set. So the test set is basically 0.33. So we're using the training set as 66% of the data, and the test set would be the 33% of the data. And so basically, this is how we are building the model. And this is what we are doing to predict based on the model. Okay. Now, once we have done the prediction, we just want to see once we have built the model, we just want to see the mean absolute errors and different metrics of this particular model. So it looks like when we did the linear regression, so this is as simple as we built a linear regression model, we basically use the training data set to build the model, and then we use the test data set to predict on the model. So understand this, okay? And so it shows us that the MA is about close to 9.39, is about 9.39, right? And so this is not good enough for us. So so what we're doing here is I'll go into the details here. So we are using a decision tree regressor to understand which features are actually important to improve the model, right? I mean, obviously that there was not a strong enough correlation, and so we are using the featured which features are showing a strong enough correlation. So from this, I'm taking a couple of features for building the model, right, with the X and Y. Okay, so what I'm doing here is I'm just using just the two features for building the model, and when I build the model, I'm also it did not help. I'm just getting the MAE of 10, and so that is not helping either. So reducing because there's not a strong enough correlation to clearly predict trip distance or trip duration, basically, right? So reducing the features did not make any predictions better. So that is observation. So what I'm doing here is the next step I'm doing here is I'm removing the outliers, seeing if that helps, because we have some outliers, and so we are saying if let me just concentrate, because most of the trips are happening within where the trip duration is less than 20, right? So I'm saying, okay, let me do some prediction, build a model on that. So I'm taking a set of rows where the trip duration is less than 20. So the Y is basically the trip duration, and the X is everything else, right? So same thing, right? I'm building a linear regression model, fit, and the model predict. This gives us the MAE of 3.47, which is actually great. So which means I can very reliably predict, if you tell me the trip distance, I can predict the trip duration, basically. So that's what this graph is very reliably indicating. So with this I can productionize the model. So I can say, if you tell me any value, where it is, where the trip duration is less than 20, then I can, I can tell you the trip distance and things like that correctly. Okay, so machine learning, right? So the conclusion, so I'm drawing the conclusion from this, right? So, so in this machine learning, so we show, how we are using a set of all the parameters to build a linear regressor model. But since we did not get an MAE of less than 5, so we did, we did a decision tree. And then we went about another iteration to see if we can, focus on just the smaller trips, basically, right? Because our model, our graphs show that, most of the trips are happening within that, less than 20 minutes duration. So, so that's what we are doing here. So we can reliably build a model. We can use this model for doing the predictions. Okay. So that is about the model building, machine learning. Okay. Now I'm going to jump into how, we are going to use the model to do, to deploy the model. Okay. So for this, what I'm doing here is, I'm just, because it has all the different columns, for me to share, a particular number, to say, it showed us, a trip duration of this, because, it might be dependent on so many other variables, right? What might be a little confusing. So for this exercise, what I'm doing here is I just kept the model very, very, very simple. Okay. So what I'm doing here is I'm building the model that predicts on trip duration based on just the trip distance. Okay. So which means I'm just dropping all the other columns. I'm just going to show you, more reliably that, if you tell me the trip distance is such and such, then the model can predict the trip duration, right? So I'm going to show you a good example of that. And also, since we know from the observations here, right, I'm also dropping the values that are, the trip duration that is less than 20. I mean, just to keep this very, crisp. That's what I'm trying to do here. So, so in this place, I'm just keeping, I'm using the iLock method to just focus on the trip duration, trip distance. So I just got only those two columns. And I'm seeing the distribution of the trip distance. I'll tell you why I'm doing this thing. Because I want to show you a good example of, because these are unique values. If it is, if this value is only appearing once, which means, I can see what the trip duration is in the data set, for instance, right? So I just want to see, I can show you how the model is predicting it more accurately, right? So that's the reason I'm doing this. So I'm just taking some examples from where these values are unique. When the values are not unique, so it does the neural network building, and then it comes up with a prediction, right? Which is a little confusing to show in this particular class, but so I'm just showing you like this. So I'm identifying, from that data frame, what are all the data, data sets are showing. In this case, the trip duration should show 14 when the trip distance is 3.065, right? But in this case, this shows you, right, if it's 2.137 or 1.582, the trip duration is showing as, 10. So, but this might be a very clear example for you to see what, how the model is showing us, right? So what I do here is I build the model, same logic, right? Test, train and test, fit, predict, and then yay, that is good, right? So I got a very precise, it's less than 5, so which is good. So I'm going to be using this. So here's what I'm doing right now. So this is where, I did some work and figured out, I'm actually, saving the model. So I use a package called as pickle.dump to save the model. So once the model is saved, here is where I'm loading the model back. Okay. Now, okay, so basically, what this confirms is that, I can save the model, I can load the model back for testing, right? So, which is good. Now I'm using this model to predict, okay? This was some exercises here. So let's see here. I'm just going to jump here. Okay. In this place, I'm predicting. So let me see what the model is telling me, right? Because it is built a machine learning model. I just wanted to see, what it is predicting. So if the trip distance is 3.065, it's predicting that, the trip duration is 16, right? So when I attach this model to a Flask application, I should be getting this, the same value. So that is what I'm trying to show here. Any thoughts or questions so far? Okay. All right. So that's great. So what we did right now is we did the machine learning model building. We went through iterations of building the model. And for this exercise, we're just taking two features, trip distance and trip duration, and we are predicting based on that. Okay, got it. So what we're doing right now is we're building the Flask application. So for Flask application, we are building the application.py, and it needs HTML, and we need the model file. Basically, that's all it is. Okay, so in the application.py, all we are doing here is, so when somebody is doing a post or a get, it gets the values from the screen, right? And then it does the value predictor. It loads the model, and then it does a predict, and then it prints the result. So that's all this is doing basically. Okay, when the user types in distance, it takes the value, loads the model, does the prediction, and shows the results. Okay. And so this is the UI. So basically the UI has, a text box for, trip distance, and then it has an output for trip duration. Okay. So if I can show you that. So it's running in my local. Okay. So I'm going to take this value. So what we are actually showing here is the model is predicting that the trip duration would be 16.76. And that matches with, so this confirms that we're using the model, right? So obviously, you can try with different numbers, right? You can do 1. So if the trip distance is, let's say 1 mile, I think it says, the trip duration would be 9.15, right? If the trip duration, trip distance is 2. So this is basically based on the data that it has built a model based on that. Okay. All right. So going back here, so is that clear? I mean, so how, we took the model, we built the model, we deployed the model, and we built an application to, leverage the model and, use it for making the predictions basically. So this could be, I remember a long time ago, right? For giving the credit card, the user, the customer service person might say, what is your age? What is your, income level? How many people in the family and all this stuff. And, on the phone, they may say, okay, you're approved for credit card or you're not approved for credit card. So I can imagine that, this is the similar thing. So there's a model that, that's built. And then based on that, they have, the customer service person, enters all of these values. And based on that, you're given a decision whether it's, whether it's a yes or a no, right? In this case, we are just predicting the trip duration based on the what the user is inputting here.
By having this unique value, you meant like unique distance value, you meant like finding the anomalies.
Finding the unique, yeah, no, basically what I'm saying here is I just took an example, right? And then, using that unique value, I mean, so if I can put in a value of, let's say 001, right? I may not be able to precisely show you why it came up with that particular number. So just to show you an example, right? How did it come up with this number? So if you look at the values which has 001, there's about 296, So it's just building a machine learning model with, about 296 linking, right? So that's why I said, let me take a unique value from here and then see how it shows, how the model can show you what the value it's predicting, right?
Means your model is accurate enough to have the value which is nearer to the actual data as well.
That is right. That is right. So in this case, that's why I took this unique value, right?
14 and predicted as 16, if I'm right.
That's right.
Very accurate. Yeah.
It's close enough, but with, if the value is like, that is also with this, 3.27 MAE and things like that. So basically what I think it's doing is it's just trying to draw a straight line and saying, okay, I can predict close enough to this thing with this, with this range of error or things like that, right? So, so that's what, the model is showing us. Yeah, so in this example, so basically, you can take a look at this thing, right? So it's very well organized. So here down below, I'm just showing, what the Open Mobility Foundation is all about, where you can get the information, what is MDS, how SF mobility data is there, LA mobility. In this case, we did Louisville data. So, just to summarize, right, MDS is getting more and more popular, and a lot of cities are trying to standardize and start leveraging the benefits of the MDS. So a lot of vehicle providers are, supporting to the specification, and they're sharing the data with the city, and so the city is making recommendations. So it's it's a growing movement to standardize, how how the people can share the sidewalks and things like that, along with the operators that are operating their devices, right? So that is about MDS. In this use case, MDS has a lot of things, the complaints, as well as, it has a lot of things. But in this example, we took the trips data from the Louisville, and then we did some cleanup, we built the model, we deployed the model, and we created an application to leverage the model, basically. Right. Any questions? Was it a lot of detail, guys? I'm not sure. Any questions or thoughts? Hello? Hey, Sudha, can you hear me?
So about this Flask app, I've just read about it, but do we have some APIs ready-made available for deploying?
So this is how we're deploying it, Kritika. So we are loading the model. I mean, the model is deployed here, right? So we are just saving the model as a model.bin, right? I think you remember that, maybe. Yeah, so here. Right.
APIs with Flask is like, do we have to write separately coding on it, or is that ready-made APIs which is available that could be used for deployment?
So this one you have to write. So basically, it is a MVC framework, basically, right? Model View Controller framework. So it basically takes the routes. If somebody types in slash, what does it have to do? If somebody types in slash, user slash ID equals something, what it has to do. So it's basically like an MVC application. You can take this as a starting point if you want, right? And then you can expand based on that. And so here is a HTML. So it just needs, this is the view. And this is like the controller, basically.
Okay.
All right. Any questions? Anything else, Sudha?
Hi, Suresh.
Yeah.
Yeah, can I ask, so what is the extra secret sauce of AI here on top of just running the ordinary least squares regression? So meaning like what additional sort of predictive power are you getting out of AI on top of just using the standard OLS regression?
So if there are a lot of rows or columns, and then in this, there was no strong predictor for the trip data to trip duration as we see that. But if you want to make a decision based on a lot of columns, then this model would be leveraged to predict the outcome from that. So this is an example of how you can leverage building the model and predicting based on let's say you have a use case, and then you can use it for that, basically. So this is just an end-to-end walkthrough of how you build the model, how to deploy the model, and how do you leverage the model to make some analysis, or make an application based on that.
Okay, so if you compare the results you get based on predictions just based from OLS, ordinary least squares regression, and your model, like by how much improved accuracy do you get with your model versus just the OLS regression?
So I think by the OLS regression, I think you mean the linear regression, or is it something else that you mean?
Yeah, the linear regression, the OLS.
So in this case, right? So in this case, the mean absolute error in the beginning was about 9, right? So let me go up here, 9.39, right? With using all the columns and things like that. So what we did here is we iterated on that to get the errors to be less than 5, which means 95% accuracy, basically, right? Anything above 95% is better. So in this case, it's close to 90%. We're just trying to improve it. So what we did here is so I'm just showing you this example. I'm not going to the, trip duration to trip distance. So in this case, what we noticed is when we used all the parameters, we got about 90% accuracy. And so in this case, we said, okay, let me focus on only the features that are, important, but that did not show us that, we are improving on the errors. We are improving on the MAE. And so what we did here is, so what we are saying here is, we can build a predictable model if we just focus on removing the outliers and focusing our application only to be, where the trip duration is less than 20. So which means what this is saying is, if an application is there, where, it's less than 20, the trip duration is less than 20, we are able to show that, we have a 96% accuracy of the model, basically. Right, so it went from 90 to improving it to 96%, basically, with this thing.
Okay, thank you, Suresh.
Yeah, thank you. So that's what I'm observing here as well. So if you look at this observation, I'm saying from 9.39, it dropped all the way to 3.47, basically, which is a good. So which means I can depend on this model when we have the values, less than 20, when the trip duration is less than 20, the model can clearly predict the trip distance basically, or the trip duration basically. That's what it's trying to say. Any other questions?
This is absolutely such a wonderful presentation. I can't tell you how much I'm getting out of this. I'm actually in a class, another class. It's a data visualization class with Python.
Oh, okay.
And it would be very helpful if I could use these slides and maybe even the recording of this. Think about it maybe for the class project, so I can get my mind around it. I'm a liberal arts major. I'm not in any way very good with math and the STEM classes. So if there is a way to share those slides, that would be great. Thank you.
Sure, I'll do that. So I'll share it with you, and maybe you can share it across.
Yes.
Perfect. Thank you, Henry. That was good. Thank you. Okay. If there's no other questions, I'll hand it back to Sudha. Thank you, Sudha.
Awesome, Suresh. This is fantastic. Thank you, everybody, for staying back and being here. And we did this as a whole new segment today. So maybe, we can learn from more of our other students. So